Effects of atrazine on the northern leopard frog, Justin Forkba and Jack McInfoy.
Big picture, agriculture and conservation are two important entities to the state of Iowa. Farmland makes up 92% of the land in the state, and Iowa leads the world in corn, soybean, and grain production. Nature conservation is used to protect species from extinction, maintain and restore habitats, enhance ecosystems, and protect biological diversity. Farmers can apply a handful of products to protect and enhance their crops, and at times, these products can have detrimental effects to nearby environments and species.
Atrazine was the most widely used herbicide overall, applied to 56% of planted acres. Atrazine interferes with photosynthesis in broadleaf plants and grasses, and once plants take it up, they dry out and die. Atrazine acts as an endocrine disruptor in animals and humans. The endocrine system is responsible for hormone activity, and atrazine can alter delivery of key hormones that are involved in development. The northern leopard frog is indigenous to Iowa and is easily found all over the state.
Our project. What effect does atrazine have on northern leopard frog? We had a control group, a high concentration group that received 5.75 micrograms of atrazine, and a low concentration group that received 0.385 micrograms at an optimal temperature, which was 62 to 63 degrees. We also had a control high and low concentration kept at room temperature, which was 68 degrees. The larvae were observed under microscopes every 3 to 5 days. We used the Gosner stage system of development, which is pictured there on the right, to determine what stage each larvae was in.
Our hypothesis. We hypothesized that as the concentration of atrazine increases, the mortality of the tadpoles will increase as well. We also hypothesized that we will see a slower rate of development in tadpoles that encounter concentrations of atrazine compared to the control groups.
So the control group at optimal temperature. We are in Gosner stages 6 through 27. We noticed that temperature seemed to have an effect on the rate of development, although it was only a few degrees colder compared to the room temperature. As of April 26, 4 out of 8 larvae are in stages 19 and above. And pictured on the right, we see a really good picture of one of the larvae that is doing well developmentally and is right on track. And here are some more pictures. These two look very good in terms of development. The one on the top left here seems to be developing a little bit slower compared to its others, and the one below that is still in its embryo-like stage.
Low concentration at optimal temperature. As of April 21st, 5 out of the 8 tadpoles have developed the Gosner stages 23 through 27. 5 have some muscular function, but not as much as the control group, and they're not as developed either. Some in both the low concentration cohorts have developed lumps on parts of their bodies. As of April 26, 3 larvae are deceased and have decomposed. And here we have some pictures of the low concentrations at optimal temperature. The one on the left shows the lump on the body that we saw grow and develop in some of the low concentration cohorts. And the middle is still in its embryonic stages and hasn't really developed further. And the one on the right shows a good developing tadpole.
High concentration group at optimal temperature. All of them have developed to Gosner stage 17 or 18. We've noticed tissue is starting to turn gray and has started to decompose as seen on the right. As of the 26th, all 8 larvae are deceased due to the high concentration of atrazine, and it took about 10 to 12 days for the atrazine to take full effect. Here are some other pictures from the high concentration group. We see the tissue has turned slightly gray and the bodies have started to decompose.
Control at the room temperature. As of April 21st, 7 out of the 8 larvae are in Gosner stages 23 through 28, and only 1 of them have stopped development and have started to turn gray. As of April 26, they all exhibit strong muscular responses and have good mouth development. They're developing at a faster rate compared to their optimal temperature counterparts. And here are some pictures of the tadpoles are at control room temperatures. As you can see, with the one on the right, you can kind of see its mouth and its eyes as well. The one on the left has good developed eyes and good muscular response whenever we saw.
Now the low concentration group at room temperature. All larvae have developed to stage 20. We have noticed tumors that are present on the majority of the larvae all over their bodies. As time goes on, we've noticed muscular function has decreased and most larvae have started to decompose. And as of the 26th, all larvae tissue has started to turn gray and decompose. It's a good picture on the right here where we can see some deformities in development, the tumors along the bottom side as well on top of the head. Here we have some more examples of the tumors grown on the belly side, some deformity in development, another tumor picture where we have one on the head, another picture where we've noticed the tissue turning gray and some deformity in development.
High concentration at room temperature. Most larvae have developed to stage 18 through 20. Only one of the 8 seem to be developing, while the others have stopped developing or are starting to decompose. Most show decreased muscular function as of April 21st, and then some have developed tumor-like lumps on them as well. As of April 26th, all of the high concentration room temperatures are deceased. And the picture shows the deformed body and like the lump on the tadpole as well. We have some more pictures with on the left, you can see it's not as developed and it's decomposing at a great rate. The head is kind of unrecognizable, and the tail has lost its fin, and it's only stout and like bony. The one in the middle just didn't start developing. It's still in its embryonic state, and the one on the right, it looked like it was further along on its development, but has also started to decompose.
Our conclusion. Based off what we observed, atrazine slows the development and increases the mortality in northern leopard frog larvae. Larvae at room temperature developed better than those at optimal temperature. Therefore, warmer temperatures cause development to be accelerated, while cooler temperatures slowed development. On the right here, we have a graph of the frog survivability, where we had 15 larvae out of the 16 total survive. And the low concentration, we only had about 5, and we had 0 out of the high concentration groups survive. So this just reinforces our hypothesis of how mortality is increased as concentrations increase. And we would just like to take a second to thank Dr. Broadman, as he served as an exceptional facilitator and advisor for our Biology 300 research experience. And we'd like to take a minute to thank you for watching our presentation. We worked hard and it is appreciated.
Thank you.